Hello all and welcome to this video. So linking in nicely from last week's video, today we're going to be discussing everything to do with immunology and the gut microbiome. Now you may have heard the saying that 70% of your immune system is located in the gut microbiome, and today I'm going to be describing and breaking down exactly what that means. The area of the gastrointestinal tract where this takes place is called the gut-associated lymphoid tissue, or GALT for short. So the gut-associated lymphoid tissue is a complex network where immune cells are essentially trained by the gut's microbiome to distinguish between harmful pathogens and beneficial substances. So there are four key main areas of the gut-associated lymphoid tissues. The first one being Peyer's patches. So Peyer's patches are organised lymphoid tissues that are located in the small intestine's ileum, and these are essentially critical immune sensors for the gut. They contain various immune cells such as microfold cells, dendritic cells, lymphocytes, and basically these cells capture antigens, triggering local immune responses to either fight pathogens or induce tolerance. So the next area of the gut-associated lymphoid tissue that I'm going to discuss are isolated lymphoid follicles, or ILFs. Now these are distributed throughout the gut and are dynamic immune structures in the gut-associated lymphoid tissue that respond to microbial signals to initiate IgA immune responses. They are smaller than Peyer's patches, but they do contain similar cellular structures. This includes things such as germinal B and T cells, as well as follicular and dendritic cells, and these are all located beneath a special layer of the gut called the epithelial layer. This also contains microfold cells. So ILFs are really important for mucosal immunity, contributing to homeostasis and immune surveillance in the intestines. So the next key area of the gut-associated lymphoid tissue is the appendix. Now, it's interesting because the appendix was first thought to be a useless organ. My brother had his removed when he was 8 or 9 as it had become inflamed. It was about to rupture, so they performed emergency surgery and they removed his appendix. Now, it's interesting that the thought process was that it was a useless organ. If you think about it, the appendix becomes inflamed. And when we look at that inflammation, it's to do with bad bacteria, essentially, that's causing inflammation within the appendix. So it's interesting that the thought process was that it was a useless organ, because if there's bacteria in there and it's next to the gut microbiome, surely there's some kind of interplay there, right? So it turns out that the appendix does contain abundant lymphoid tissue, and it functions as a reservoir for gut microbes. It also supports immune education by presenting microbial agents to lymphoid cells. And as I just suggested, it plays a role in repopulating the diversity of the gut microbiome after certain disturbances. For example, some kind of an infection, and you may have been put on antibiotics. Those sort of things. After that disturbance, the microbes that have been kept there as a reservoir will help repopulate the gut microbiome after such disturbances. So the appendix is essentially considered a safe house for the microbiome's microbes after disturbances, and is also an active site for mucosal immunity. Now, the final part of the gut-associated lymphoid tissue, which I find to be slightly more complicated, are the mesenteric lymph nodes, or MLNs for short. So these are critical to gut immunity and primarily play an active role in defense and tolerance for the intestinal tract. Okay, so the body needs to differentiate between pathogens and then non-harmful substances. So MLNs help filter out antigens and host immune cells like dendritic cells that initiate the adaptive immune responses to pathogens and commensal bacteria. They also coordinate responses to food and microbial agents that are the site of T cell activation, playing a crucial role in the immune homeostasis. They also help prevent systemic spread of intestinal contents. So those were the key areas of the gut-associated lymphoid tissue, and we're now going to be moving on to mucosal immunity, which is really cool. So mucosal immunity is essentially the gut's specialized defense system that protects against pathogens. So it relies on the epithelial barrier, and I'm going to go through the orders of the different barriers in the gut shortly. But it relies on the epithelial barrier, specialized immune cells, and the gut's microbiota to keep and maintain balance. So IgA, immunoglobulin A, antibodies are produced in the gut lining, and this is to neutralize pathogens. An IgA antibody is a key component of the immune system. It's primarily found in mucous membranes, such as those in the respiratory tract, the digestive tract, as well as secretions in saliva, tears, and breast milk. So as I just touched upon, the gut has several layers to its mucosal lining, the first being epithelial layers, which form the physical wall of the gut. Next up is tight junctions. So tight junctions are essentially complex proteins that seal the spaces between the epithelial cells, and they prevent unwanted leakage. So you might hear of a term called leaky gut, and this is essentially where the tight junctions have become loose between the epithelial cells and allow toxic substances like undigested food particles, sensitivities, things like that to leak through the gut, and this can lead to all sorts of health effects. And finally, there's the mucosal barrier. So this is a mucosal layer on top of the epithelium, and this essentially traps microbes. And this layer is enriched with all sorts of antimicrobial peptides as well as secretory immunoglobulin A. So the order goes epithelial cells, tight junctions in between the epithelial cells, and then the mucosal barrier above them. Now, there are some bacteria, such as Akkermansia, that their job is to literally eat the mucus in the gut microbiome, so they eat mucus. Now, Akkermansia, there is all sorts of research being conducted on it, as it seems to have really positive health benefits, and it looks very, very promising. So Akkermansia belongs to a phyla of bacteria called mucinophils. So these beneficial bacteria reside in the gut lining, and they use their enzymes to break down mucin proteins that form the proactive mucus. So they use their enzymes to break down the mucin protein that form the protective mucus layer. This process is not harmful. In fact, it actually produces metabolites that help to nourish the bacteria and maintain good balance in the gut ecosystem. So this overall is essential for a healthy gut barrier and an immune function. So finally, the gut microbiome interacts with PRRs, so pattern recognition receptors. Boy, this takes me back to second year uni lectures of immunology. So PRRs regulate the immune response, and they also influence both innate and adaptive immunity, although they are mostly associated with innate immunity. So gut microbes produce MAMPs, so microbe-associated molecular patterns that PRRs recognize. Prevents pathogen colonization, and even impacts innate immune memory. This interplay is crucial for overall health. Without it, dysbiosis can occur, which, as I've previously discussed, can be linked to awful chronic inflammation and disease. So just to clarify as well, when I discuss B and T cells produce antibodies that help kill and neutralize invaders like bacteria. T cells either kill infected cells directly or help regulate and coordinate the immune response by directing other T helper cells. Now, I appreciate that this video has been very, very immunology heavy, and if you don't have a science background, this may be quite difficult to understand. So what I've done is I've come up with some real life type analogies to try and help you understand everything I've just spoken about. So firstly, I would like you to think of the GALT, so the gut-associated lymphoid tissue, as a military academy. Okay, so this is where immune cells are trained, and they learn which faces are pathogens, so enemies, and also which are allies, so food and commensal bacteria. So going back to Peyer's patches, I would like you to see them as border checkpoints. So they're essentially like airport security checkpoints in the small intestine. So microfold cells are the scanners, and they sample what's coming through, so for example antigens, and then they pass information to immune officers, which are dendritic cells and lymphocytes, who then decide who to let through or raise an alarm. Then moving on to ILFs, isolated lymphoid follicles. So these are essentially neighborhood watch. So they're smaller, but they're scattered everywhere, and just like neighbor watch groups that are scattered throughout a city, they may not be as big as a central airport security, but they're constantly on alert and ready to activate local defense if something suspicious shows up. So the way I would like you to also think about the appendix is like a backup hard drive, okay, or a safe house. So essentially it stores copies of your important files, such as commensal bacteria. So if your system crashes due to antibiotics or an infection, it helps restore order by repopulating the gut with healthy microbes. And lastly, mesenteric lymph nodes. So these are essentially the customs and command centers. So these act like customs officers and command centers. They filter out what's allowed deeper into the country or the body, and direct T-cell officers to either attack intruders or stand down when it's harmless. Now, going back to mucosal immunity and immunoglobulin A, so IgA, these are essential non-lethal police forces, okay? And what I mean by that is IgA antibodies are essentially the peacekeepers. They have foam bullets instead of guns. They neutralize troublemakers without creating collateral damage, like IgG, which causes full-on inflammatory battles. The mucus layer itself is like a moat around a castle. It traps invaders before they can breach the wall. In fact, we can use a fortress analogy for the gut barrier. So we have the epithelial cells, which is the castle wall. We have the tight junctions, which are the motor holding the bricks together. The mucus layer is the moat, trapping invaders before they reach the wall. And the IgA antibodies, which are the archers shooting arrows at the invaders in the moat. Going back to that species of bacteria called Akkermansia, think of them as the janitors or the maintenance men. So they're like janitors in the sense that they eat away extra mucus but recycle it. So they tidy the moat in the process and produce helpful nutrients to keep the castle strong. And then PRRs. So these are essentially the security sensors. So pattern recognition receptors are like motion detectors and smoke alarms inside the castle. They don't know the name of every invader. They recognize suspicious patterns like MAMPs, so microbe-associated molecular patterns, and trigger an alarm to mobilize defenses. And finally, we have B and T cells. I want you to think of these as the special forces of the immune system. So B cells are essentially archers firing antibodies to tag enemies, and T cells are elite soldiers. So while some are snipers like killer T cells, taking out infected cells, others may be commanders, so helper T cells directing the whole army. So the key three main takeaways I'd like you to take from this video are: your gut is your immune training ground. So the GALT teaches immune cells to distinguish friend from foe, balancing defense with tolerance. The gut barrier is your fortress. So epithelial cells, tight junctions, mucus, IgA, all of these things work together in conjunction to keep invaders out while maintaining peace inside the gut biome. And finally, a healthy microbiome is the key ally. Beneficial microbes, for example Akkermansia, support the moat, train the immune army, and prevent dysbiosis-driven disease. I guess the main message I've been trying to get across is that your gut microbiome is your biggest ally. So please nurture your gut microbiome and it will fight for you. So well done for sticking with me till the end. I appreciate that was very immunology heavy. But yes, the gut microbiome is where the majority of the immune system takes place and where the majority of your immune cells reside. There is a lot going on there. They're kind of just the basic systems. There is even more as you deep dive into it more, but I'm going to keep it just for this episode, and we're going to stop it there. Thank you very much for watching. I hope that helps you understand your immune system and your gut microbiome more, so please, please, please take care of your gut health. I will be doing another video on how to optimize that. But for now, thank you very much for listening, and remember that was science made simple.